Welcome back everyone, this is Shadow Drake, and as you can tell by this motherboard, we are going to be doing the logic sorter tutorial. But it does not use this motherboard, which I am thankfully glad for because I hate it. I really don't like it. It's gotten better, mind you. Like, you used to be unable to move anywhere and it'll close out, so I guess I'll give it that. But it still has the problems where sometimes a client on a multiplayer server can't do anything with it. So let's go back to our relatively clean spot and go with the logic sorter. So the logic sorter is definitely probably the next stage as far as printer logistics based system. So what I am going to do is cover through the sorter, the commands, and then what we can kind of do with it that we may or may not have the same functionality on the normal sorter with that awful motherboard. So I'm sure you see that right now you see unsorted and sorted, and I'm pretty sure that right now the only things that are allowed in are steel sheets, sort to the right, as well as stellite, sort to the right. Everything else will go to the left. Yep, everything else goes to the left. So that's how I know that it's sorted versus unsorted. So yeah. In addition to that, we also have the mode. So I'm on the wrong one. Logic sorter. We also have a mode, which, depending on what mode you set it in, determines whether it will evaluate the entire stack or how it needs to evaluate the stack. Either all pieces of the stack need to be true to sort, any conditions in the stack need to be true to sort, or none of them need to be true to sort. And so what that means is, if I were to go to 0, that means I need to see steel sheets and stellite ingots go through the sorter at the same time for those to come out through the sort. And as you can imagine, that's not possible. I don't think even if I put them inside my backpack, it would still work. Yeah, see. So that's the all mode. There are advantages to using it. Oh, and of course there's the none mode, which means that now my stellite and steel sheets go to unsorted, but everything else goes to sorted. So, yeah. So we're going to be playing around with this mode quite a bit with our stack commands. So let's go over the stack commands. There is nothing to read as far as the stack is concerned, so that makes things a little simpler. I do have my laptop here, and this housing will be the one that writes to it, so we're going to be using that. So, first things first, not that. First things first, let's go over the commands. So, in the sorter instruction, the very first command opcode, and I'll actually do these in order because this one is not as crazy as the printer. The first one is the prefab hash equals. So basically, you tell the sorter, if this prefab hash goes through, then you sort. And then of course the mode fully determines everything. So that's what we're using the first go. Let's go to my logic, skip all this stuff, and so here's opcode 1, prefab hash equals. So if I got equals to steel sheet, ooh, I don't have a clear command here. That could be a problem. I have prefab hash equals, and you see kind of follows the same thing. You know, I got my steel sheet hash prefab ID, shift it to the left 8, add my code of 1, done. And again, you could also just type in sorter instruction prefab. Is it prefab hash equals? Filter prefab hash equals. That also works too. And where's my stellite? This is what did I do with it? Okay. I don't know what I did with it. there it goes. Oh, there it is. See? Still works. Still sorts. So that's a pretty simple command. You got a specific set of stuff that needs to be sorted. Use opcode 1. Now, we also have opcode not equals. So now, in a sense, that's kind of like the opposite of what we want. So now we want to sort things that are not equal to steel sheet, or things that are not equal to stellite. And this is kind of where our sorter mode can be extremely finicky, because depending on what you have it at determines on how it sorts. So this should still go through sorter under any, because while technically it's a steel sheet, it should still qualify as not an ingot. It goes through unsorted. Interesting. Why does that go there? Steel sheet. Code. That's really interesting that that one went through. Let me just do that again. Zeros and ones. I might be having some issues. Alright, steel sheets. Where are you going? Unsorted. Stellite. That's really weird how that one goes there. Where are you going? Did I mistype that? Move materials, steel sheet. 8. This is why. I put opcode 1 here again. See? You can find little bugs of that. Still goes... There we go. Now it all goes right. That's the behavior expected. See, because now I'm looking for not equals. So what's going to happen is it's going to check the stack. Well, at 0 it says, hey, I don't want it to be steel sheet. So when I put a steel sheet in, it's like, okay, that's false. So that means now I need to go through unsorted. But then it checks ingot stellite, and that would be true. So now it's like, okay, so I have a false and a true statement. With the any mode, so long as any of the stack commands evaluate as true, it'll go to sort. And literally everything will do. Now, if I put it on all, see, my pipes go through the right, and my steel sheets go, and the stellite go through the left, as expected. Now, so long as none of them are true, I think that's going to be a point where everything's going to go left again. So you can kind of see. There's a little bit of logic to think about. You definitely need to test these cases to see exactly what it needs to do for you. So that's operator code 2. Now we're going to get to the weirder ones. Sorting class compare. Every device has a sorting class, and basically it comes with this. You can find the sorting class or specific ones to go how devices could be done by typing sorting class. Sorting. I don't know why. Why didn't it take? I swear, sometimes this does not like me. Yeah, see? I don't know why. So sorting apparently works. So how I got there, here, you press X, then search for sorting. Apparently sorting class does not work. And you can see we have constants for different types of sorting classes, like appliances, atmospherics, clothing, default, food, ICs, kits, ores, resources, storage, and tools. And so this is going to be kind of a trial and error, because right now the only source for what we have is kind of in the wiki, but not all devices have a very easy to define sorting class. And so that's what I have this little setup here for. So if I recall right, I don't know what a sorting class of 3 is. I want to say that that's resources, because technically that's a resource. But you see, steel sheets also qualify as that. Pipes, however, have a different sorting class. So, yeah, it it it's more in depth. It definitely is more in depth. You definitely got to do a lot of trial and error for that. So let's just put it at 0. So we're gonna sort class at 0. And right now, I'm looking for equals. This one is the one that has a condition operation, and that is equals. I don't condition. No, I think that's just like not equals. Yeah, it's not easy to search for them, but you have equals, not equals, greater, less than. I'm honestly not entirely sure what will happen when I do less than or greater than for a sorting class. So we're just going to look for sorting class of equal to resources. So that should mean that steel sheets and my ingots should go to the right. You can kind of see that. But my pipes will go left. So you can kind of see what is classified as resources, but there's not very easy rhyme or reason for it, so it's going to be kind of tricky to use sorting class. But you can use sorting class because you could make like a slot check tool and potentially find out what class this is. So at least I'm reasonably confident that a lot of this stuff will go there. What about memory? Yeah, okay. Okay, my uniform? Yeah, it's completely different. How about my backpack? Same as my uniform. Anyways, to not get terribly distracted, so there's sorting class, and it's kind of vague what is what. So, let's remove that, and let's put slot type. The next one is slot type compare. This one is a little bit more easier to understand because it uses slot class, and it's a little bit easier to tell. See, right now I'm gonna sort based on slot class ingot. Man, tongue twister. Slot class? Okay, that one for some reason works. And you can see you have a lot of different slot classes. And the way that these works, let me find uniform. Uniform, apparently. Uniform. So you see on the uniform you have slot types. So the uniform has 2 non-slot types, one for specifically access card and one specifically for credit card. So basically the logic is any kit, item, or tool or anything that can go in a specific slot will fall upon a specific slot type class. It's weird. Yeah, slot class. Yeah, there's sorting class, slot class. Yeah, it's very easy to interchange them. And once again, link in the description for the wiki that basically has most of them. And so you can more easily find and put stuff around. Like, if you really, like, resources including ingot and some building materials. At least here we have a slot class for literally ingots. So that at least makes it easier for you to get only the ingots out. So that's what we'll do. So, for example, we'll move the slot class dot ingot. I don't know what that number is. Equal condition, same bit shifting. Same bit shifting, so yeah. For the slot type, 16 bits. Shift of 16 bits, condition 8 bits, and then the opcode of 4. Make sure I got the opcode of 4. So yeah, there we go. I'm going to put that in 1. And now, only ingots can go on the right side. So, my stellite is the right, walls go left, copper goes right. Yep, see? And then you got the same condition, so any and none. Honestly, the negate, using the nones or any not equals can get some pretty interesting combinations of stuff going, so be definitely test your system to see exactly what you need. The final command is going to be... Oh, sorry. Next command is filter quantity compare. Now this one is a very interesting one that I found in my, at least in my opinion. What it is it doesn't apply to the next code. What it is you put a literal quantity of number of items to go through. So in this, so let's put a count of 10. So we're going to let only 10 items through, you know, equal to 10 items with the code of 5. So yeah, shifted 16 bits, the count 16, condition 8, gonna OR it, gonna add it, and we're gonna put it in sorted code 0. So it has to be an exact count of 10 in this case. So what does that mean? I have exactly 10 pipes, goes to the right. Oh, whoops. Exactly 10 pipes and any goes to the right. I remove one pipe, up goes left. And see, this is how you can send the exact quantities in a specific direction. We can do the same thing here. 10 steel sheets, right. 10 pipes, right. 1 ingot, left. 7 steel sheets, left. And then, again, condition operators. I thought that was kind of cool. I kind of like that command. Now, the final command is the limit next execution. This one is kind of a doozy. But say you only want to let something hold true a few times. That's what that final opcode is. So we'll do the same thing. The whole exactly equals to 10. Actually, let's do less. Less than 10. So less than 10. So we're going to do, for opcode 6, we're only going to allow this command to work 5 times. So this count is how many times you want it to work, and then opcode 6. So bit shifted 8. Put it, sorter code, yeah. So now, I'm at 1. So now, this is clearly greater than 10. Left. This 1G is less than 10. Right. But that will only happen 5 times. So that was 1, 2, 3, 4, 5. Left. See? Oh boy. Now, let's see what happens when I put it in the none operation. So that should mean that goes right. That goes left. 2, 3, 4, 5. Right. There you go. Ooh. So that is the brief overview of all the commands. Now, this is kind of where you can start to get kind of doozy. Remember how I said that you could have kind of like a networking, say you print exactly some amount of steel sheets and go this way? So what if you're ready to print that? You give it the all command. So we want exactly 10 steel sheets to go through. So let's do this. Let's comment out the limit execution. Actually, no. Let's put that a 0. We want exactly equal 10 sheets. Let's do code 1. Let's put, I'll just copy and paste it. It's literally the same code. So, exactly equals to 10. And steel sheets, but that is going to be code 3. Now, if I got that right, 7 steel sheets will go through unsorted. Everything else will go through unsorted. However, 10 steel sheets should go through, sorted. But remember, I limited it to only happen one time. So next time, unsorted. Interesting. It's really interesting how that works like that. That's kind of where I like the logic sorter for this. You can, as far as the networking side of things goes, you can get pretty complicated in what you want to move stuff around and where. And you can also do the same thing with the sorting classes. Like, for example, same thing, you know, when it first comes out of the printer, chances are you may want some of the atmospherics related stuff to go one direction, and you may want other stuff to go in other directions. So you could look for specifically sorting classes, slot classes, my bad. You can look for slot classes that could work for the what you're looking for. And if you can't find a slot class that'll work, you can go for the sorter class. So, sorter class. Is it class? What was that? I just had it. Yeah, sorting class, sorry. Yeah, you could try sorting class atmospherics. See if that moves only atmospherics around. And if that isn't everything, you could probably put some conditions to limit that stuff. So yeah, this is the logic sorter. You can definitely get pretty complex with how you want to do this thing. But I mean, if all you need this for is, you know, moving ores to a dedicated silo after you centrifuge deep miners and stuff, you probably won't need a lot of logic to get it working, because after all, you probably only want iron to go one direction. Or maybe you just want to get uranium out and let the rest of that stuff go somewhere. You just build a condition using the correct mode that you need. And then, yeah, just create a command, send it in. Or at least in my opinion, it's better than the motherboard. I really don't like the motherboard. So yeah. Hopefully this at least helps you to be able to program your own logic sorter motherboard. And, you know, maybe can start making some complicated logistic systems out of this. Alrighty, so this is Shadow Drake. Next time I'm going to go through the trader stack commands. And yeah, I'm gonna need a better setup for this, because that's I'm getting claustrophobic in here. And I don't think I can fit more in that hole. Alright, thank you for your time. Hope to see you then. Thank you and goodbye.